On November 5th, 2018, at a distance of roughly 11 billion miles from Earth, a 41-year-old spacecraft crossed an invisible boundary in a NASA briefing room and leave scientists visibly unsettled. It wasn't a voice. It wasn't a word. It wasn't anything anyone expected to actually be able to hear, because there's no air out there, no medium for sound to travel through, the way it does inside your house right now. And yet, when researchers took the raw data streaming back from that spacecraft and ran it through a speaker, an eerie, rising hum filled the room, a sound with no earthly source, coming from a region of space no machine built by humans had ever entered before. And that spacecraft is Voyager 2. It launched on August 20th, 1977, 16 days before its twin Voyager 1, and it is still out there right now, still transmitting, still calling home across a gap so vast that its signal takes over 19 hours to reach us, traveling at the speed of light. This is the real story of what Voyager 2 actually sent back from beyond our solar system, why it took scientists years to confirm the recording wasn't some kind of instrument glitch, and why the window to ever hear from this machine again is now closing for good. When Voyager 2 left Cape Canaveral in the summer of 1977, its mission on paper was almost modest by comparison to what actually happened. Fly past Jupiter and Saturn, capture some images, gather some data, and eventually drift into silence once the fuel and the funding ran out. Nobody involved in building it, not the engineers, not the scientists, seriously expected it to still be operating, still making genuine discoveries 49 years later. What made the difference was a rare planetary alignment, one that lines up the outer planets in a way that only happens once every 176 years, allowing a single spacecraft to use the gravity of one giant planet to slingshot itself toward the next without burning enormous amounts of fuel. Voyager 2 remains the only spacecraft in history to have used that alignment to visit all 4 outer planets in a single mission. It reached Jupiter in 1979 and Saturn in 1981, and then, in a decision that reshaped the entire scope of the mission, engineers redirected it toward Uranus and Neptune, 2 worlds no spacecraft had ever approached before and none has approached since. At Uranus in January 1986, Voyager 2 discovered 11 previously unknown moons and 2 new rings, along with a magnetic field tilted nearly 60 degrees off the planet's axis, a finding scientists are still trying to fully explain. 3 years later, in August 1989, it reached Neptune and discovered the Great Dark Spot, a storm system roughly the size of Earth tearing across the planet's atmosphere, and confirmed for the first time that Neptune had a ring system of its own. That flyby was the last time either Voyager's cameras were ever switched on. Once the planetary tour was finished, Mission Control did something almost nobody expected. Instead of shutting the spacecraft down, they aimed it outward, toward the very edge of everything the sun controls, and simply kept listening. Before we go further, it's worth understanding something bolted to the outside of both Voyager spacecraft that has nothing to do with the science instruments at all. Each Voyager carries a gold-plated copper phonograph record, curated by a committee led by astronomer Carl Sagan. Etched into it are 90 minutes of music from cultures across the planet, spoken greetings in 55 human languages, natural sounds of Earth including thunder, wind, and whale song, and more than 100 images encoded directly into the grooves, from human anatomy to city streets to the structure of DNA. Playback instructions were etched onto its cover in case whatever finds it has no concept of what a record even is. In 1977, it was arguably more an act of hope than science. A message sealed inside a bottle thrown into an ocean so large the odds of it ever being found are effectively zero. But it is still out there right now. Riding along on the exact spacecraft responsible for the plasma readings this story is actually about. Here's where the part of the story most people have never heard begins. The sun is not simply a light hanging in the sky. It is the center of an enormous invisible bubble called the heliosphere, inflated outward by the constant stream of charged particles known as the solar wind. Everything inside that bubble exists under the sun's direct influence. Outside, it is something else entirely, the true space between stars, filled with leftover plasma, radiation, and magnetic fields from other stars that lived and died long before our solar system formed. For decades, scientists assumed the edge of that bubble would be a slow, blurry fade. Voyager 1 proved that wrong first, crossing the boundary in August 2012 at roughly 11.3 billion miles from the sun. It was not a gradual fade. It was a sharp, sudden membrane, crossed in a matter of days. Solar wind particles collapsed. Cosmic rays surged dramatically. Magnetic field readings shifted direction entirely. Voyager 1 had become the first human-made object to leave the solar system, a title it would hold alone for 6 years. That left one enormous question hanging over the entire mission. Was that sharp crossing simply a fluke of Voyager 1's particular path through space, or was it a real physical boundary that any spacecraft would eventually hit in roughly the same way? The only way to know for certain was to wait for Voyager 2 to reach the same frontier from a completely different angle and see exactly what it found there. On November 5th, 2018, it finally did. Voyager 2 crossed the heliopause, the technical name for that boundary, at a distance of about 119 astronomical units from the Sun, just over 11 billion miles out. A journey that had taken 41 years to complete since its 1977 launch. And almost immediately, its instruments confirmed exactly what Voyager 1 had shown 6 years earlier. This was not a coincidence. This was a genuine physical edge to our entire solar system, and now 2 independent spacecraft, approaching from different directions years apart, had both measured it directly. 5 separate scientific papers analyzing Voyager 2's crossing were published together in November 2019 in the journal Nature Astronomy. Each one focused on a different instrument still functioning aboard the aging spacecraft. Together, they painted the most detailed picture ever assembled of the true edge of our solar system. One of those instruments is where this story turns genuinely strange, and it is the exact one responsible for the sound that opened this video. It is called the plasma wave instrument, and its job is to detect oscillations in the ionized gas, or plasma, that fills the space surrounding the spacecraft. Here is the part that surprises most people. There is no sound in space. It is a vacuum. There is no air, no medium at all, for a sound wave to physically travel through the way it does here on Earth. What the plasma wave instrument actually detects is electrons oscillating back and forth, creating an electrostatic wave, a completely different physical phenomenon from the pressure waves that create sound inside our atmosphere. But by pure coincidence, the frequency of those particular oscillations happens to fall within the exact range the human ear can process, roughly a few hundred to a few thousand hertz, which means that if you take that raw electron data and run it through a loudspeaker, you can genuinely listen to it. Not metaphorically, literally hear it. Don Gurnett, the physicist who led the plasma wave investigation on both Voyager spacecraft for the University of Iowa, called it exactly what it was the first time Voyager 1's version played at a NASA press conference back in 2013. In his own words, it was a historic event, the first time humanity had ever made a recording of sounds occurring in interstellar space. When Voyager 1 was still inside the heliosphere, those tones sat low, around 300 hertz, consistent with the thin, hot plasma of the solar wind. The moment it crossed into interstellar space, the pitch jumped sharply higher, into the 2 to 3 kilohertz range, the unmistakable signature of colder, denser interstellar plasma pressing in around the spacecraft. That single measurable change in pitch was, on its own, hard scientific evidence of the crossing, independent of any other instrument on board. Voyager 2's plasma wave instrument, when its own data finally made it back to Earth years later, told essentially the same story from the opposite side of the solar system. Scientists measured a jump in electron density by a factor of roughly 20, almost the exact same signature Voyager 1 had produced years earlier at a completely different location, confirming beyond any reasonable doubt that both spacecraft had passed through the same kind of physical boundary. Gurnett, reflecting on what the Voyager 2 data confirmed, put it plainly. The old assumption that the solar wind simply fades away gradually the further you travel from the sun turned out to be false. There is a real, distinct boundary out there, sharper and more defined than most scientists had expected going in, something closer to a weather front than a slow fade, crossed by both spacecraft in a matter of days, rather than the years of gradual transition earlier models had predicted. There was a genuine surprise buried inside Voyager 2's numbers as well. Where Voyager 1 had found the plasma just outside the heliosphere slightly denser than predicted, Voyager 2 found it slightly warmer than expected, a subtle but important difference that suggested the sun's own bubble might be compressing the surrounding interstellar material unevenly, pushed harder from one direction than another, likely shaped by the sun's motion through the galaxy over millions of years. That is not a detail anyone could have guessed from a desk on Earth. It is the kind of finding that only comes from actually being there, 41 years after launch, still transmitting, still listening, still teaching us things nobody thought to ask about back in 1977. It is worth being precise about how that eerie translation actually works, because the process itself is a big part of why this data deserves to be trusted rather than dismissed as some kind of hoax. The plasma wave instrument does not produce an audio file on its own. It measures the electric field around the spacecraft dozens of times per second and beams that raw numerical data back to Earth as radio telemetry, the exact same way every other instrument on the spacecraft does. Scientists on the ground then take those raw electric field measurements and run them through a straightforward mathematical conversion, mapping the recorded frequencies directly onto an audible range and playing them through a standard speaker without adding, removing, or altering anything about the underlying signal. Bill Kurth, a longtime member of the plasma wave team working alongside Gurnett, has explained the reasoning simply. Making the data audible is not about spectacle. It effectively is the science, just rendered in a form a human being can process directly. That distinction matters, because it is exactly why this story deserves more trust than a vague headline about a decoded alien transmission, not less. Every step of this process, the raw measurement, the published density numbers, the peer-reviewed papers in Nature Astronomy, the named scientists willing to put their reasoning on the public record, is fully documented and openly available for anyone to check. Compare that to how an actual fabricated space story usually spreads online. It leans on vague sourcing, unnamed researchers, unwilling to be quoted directly, and claims that grow more dramatic the further they travel from the original data rather than less. The real version of the Voyager 2 story holds up to exactly that kind of scrutiny, because it was never hiding anything to begin with. It is the literal sound of interstellar plasma pressing against a decades-old spacecraft, translated into a frequency your ears happen to be able to process. And once you actually understand that, it becomes something arguably far more chilling than any fabricated alien transmission ever could be, because it is real. It is the actual physical texture of the space between stars, captured by an object that is, for now, still the only thing humanity has ever built out there to listen. That phrase "for now" matters, because the second half of this story is a countdown, and it is already running. Voyager 2 runs on a radioisotope thermoelectric generator, essentially a chunk of decaying plutonium converting heat into electricity, and it was never designed to last forever. Every single year that power supply loses a little more output, roughly 4 watts annually, and mission engineers have spent the last decade making increasingly difficult choices about what to sacrifice in order to keep the rest of the spacecraft alive. The cameras were the first major system to go, switched off permanently after the Neptune flyby back in 1989 because there was nothing left to photograph, and no power to spare on instruments no longer being used. One by one since then, other systems have followed: heaters, backup circuits, anything not strictly essential to keeping the remaining science instruments and the spacecraft's ability to talk to Earth alive. In 2023, mission controllers deliberately powered down Voyager 2's backup transmitter systems and made a series of increasingly precise adjustments just to keep the spacecraft's antenna pointed accurately enough for its signal, now impossibly faint after traveling more than 11 billion miles, to still be caught by NASA's deep space network back on Earth. That network itself deserves attention because it does just as much work in this story as the spacecraft. It consists of 3 giant dish complexes, spaced roughly evenly around the globe in California, Spain, and Australia, positioned so that as the Earth rotates, at least one is always facing wherever Voyager 2 happens to be transmitting from. Some dishes stretch over 200 feet across, built to pull in signals measured in fractions of a billionth of a watt, weaker than the power it takes to run a digital wristwatch, and pointed with an accuracy tight enough to track a target smaller than a car from 11 billion miles away. Every piece of data this story is built on had to survive that journey, amplified by equipment cooled close to absolute zero to strip out background noise, and only then decoded back into usable numbers before a single scientist ever looked at it. Voyager project manager Suzanne Dodd summed up where the mission stands with a line that has stuck with almost everyone who has followed this story since. The Voyagers have been deep space rock stars since launch. The team wants to keep it that way as long as possible, but electrical power is running low and hard choices have to be made. Most of the original 10 science instruments on each spacecraft were powered down decades ago, once their planetary targets were behind them. What has remained active is a small, carefully chosen set built for interstellar work: the magnetometer, the cosmic ray subsystem, the low-energy charged particle detector, and the plasma-related instruments responsible for that eerie recording. Engineers have been forced into an unusual kind of triage, ranking each instrument by scientific value against the power it costs to keep running, then shutting down whichever one ranks lowest whenever the generators drop below the next threshold. As of early 2026, Voyager 1 is down to 4 active instruments, and Voyager 2 to 3, according to mission tracking, with engineers openly planning to cut at least one more from each spacecraft before this decade is out. The explicit goal stated by the mission team itself is to keep at least one instrument alive on each Voyager deep into the 2030s, squeezing every last watt out of generators that were never designed to still be running half a century after launch. Voyager project scientist Linda Spilker has been unusually direct about what that actually means, day to day, for the team monitoring these signals every minute of every day. She has said that the Voyagers are exploring a region where no spacecraft has ever gone before, which also means that every single day genuinely could be their last. But she has also pointed out the flip side of that uncertainty, that the very same day could just as easily bring another interstellar revelation, because nobody, not one single scientist on this mission, actually knows what these instruments might still pick up before the power finally runs out for good. To put that distance into perspective, NASA marked a milestone in February 2026 when Voyager 1 became the first human-made object ever to reach one full light day from Earth. just over 16 billion miles, meaning that even light itself now takes a full 24 hours to cross the gap between that spacecraft and home. Voyager 2, slightly closer at roughly 13 billion miles out after its longer route through the outer planets, is not far behind on that same trajectory. Every command sent up and every bit of data sent back is now one of the longest round trips any human signal has ever traveled, using an antenna smaller than a kitchen table, aimed with pinpoint precision across a gap that keeps growing wider every second. NASA's current projection is that the plutonium generators aboard both spacecraft will likely fail sometime in the early 2030s, though the agency has been careful to note that estimate could shift again, because these two machines have already blown past every original prediction anyone ever made about them by decades. When that day finally comes, there will be no dramatic final message, no last transmission decoded in a control room somewhere. The signal will simply gradually weaken past the point where even the most sensitive receiving dishes on Earth can pull it out of the background noise. And then, for the first time since 1977, Voyager 2 will fall permanently silent, continuing to drift through the galaxy on its own, carrying its golden record of Earth's sounds and images to no one for longer than our own sun has left to live. That is the actual story sitting underneath a headline like NASA decoded a terrifying transmission from deep space. There is no hidden alien code buried inside Voyager 2's data, and nothing NASA has ever released has been kept secret and then suddenly cracked open. What is true is arguably stranger and more affecting than that framing. A 50-year-old machine, built before most of the people watching this were even born, is still out there right now, past the edge of everything the sun touches, sending back the literal sound of the space between stars on a dying battery, with a team of scientists on Earth checking every faint signal that arrives, fully aware that any one of them could be among the last things this particular spacecraft ever tells us. None of this is where the story of interstellar exploration ends either, even once these two spacecraft finally go quiet. NASA and Johns Hopkins researchers have spent years studying a proposed follow-up mission, sometimes called Interstellar Probe, designed to do everything Voyager 2 did almost by accident, deliberately, with far more capable instruments. Where Voyager 2 stumbled into its historic crossing using 1970s instrumentation built for planetary flybys, a purpose-built interstellar mission could carry dedicated plasma, magnetic field, and particle detectors engineered specifically to characterize the heliosphere's boundary in far greater detail. Nothing is launched yet, and funding remains uncertain. But the fact that serious engineering studies exist at all is a direct consequence of what Voyager 1 and Voyager 2 proved was possible. Before 1977, nobody knew for certain the heliopause was even a real, definable boundary. Now there is an entire body of published research, 5 papers deep, that any future interstellar mission gets to build on top of. That is really the thread connecting everything in this story, from the great dark spot at Neptune, to the plasma hum recorded at the edge of the solar system, to the countdown currently ticking away on both spacecraft's dwindling power supplies. Nothing about this mission was ever planned to still be delivering discoveries in 2026. It was built for a 5-year tour of 2 planets, and it has instead spent nearly 5 decades rewriting what we thought we understood about where our solar system actually ends and the rest of the galaxy begins. Every additional year, these 2 machines keep transmitting back to Earth is genuinely bonus science that nobody working on the project back in 1977 had any real right to expect. It is worth pausing here on why stories like this one so often get warped into something they are not. Real findings arrive, hedged, incremental, and attached to a named scientist willing to explain exactly what was and was not measured. Manufactured versions strip all of that away, replacing careful language with false certainty, and a named institution with a vague, scientists say that is not actually true. Whether it is a supernova that has not happened yet, an old spacecraft image reinterpreted decades later as an alien signal with no published research behind it, or a plasma wave recording turned into a terrifying decoded transmission implying something was hidden and cracked open, the pattern is the same. In every case, the real story, once you track down what scientists actually published, turns out to be stranger than the exaggerated version, not less. Voyager 1 and Voyager 2 will keep drifting long after their power finally fails and their instruments go dark. Freed from any further course corrections, both spacecraft will continue on their current trajectories, orbiting the center of the Milky Way for an estimated 5 billion years or longer, according to researchers on the mission, essentially outlasting the Sun and the entire solar system that built them. The odds of either spacecraft ever colliding with anything else out there are, by those same researchers' estimate, almost 0 across a span of time that dwarfs human history into a rounding error. And that is where the golden record, bolted to the outside of each spacecraft, since before almost anyone watching this was born, finally becomes relevant to everything else in this story. Once Voyager 2's instruments go silent for good, probably sometime in the early 2030s, the spacecraft itself does not stop existing. It simply stops talking. It keeps moving, carrying that gold-plated record outward at roughly 35,000 miles per hour, long after every person who worked on the mission is gone. There is no planned destination, no target star it is aimed at. It will simply drift through the empty space between star systems for longer than human civilization has existed, carrying a message that statistically will almost certainly never be found by anyone. That is the part of this story that deserves to actually stick with you more than any invented transmission ever could. We built something nearly 50 years ago that has already outlived most of the engineers who designed it, that is still teaching us new physics about the edge of our solar system, that is still audibly humming with the real sound of the space between stars, and that is now counting down watt by watt toward a silence that will be permanent. Every signal it sends from here forward is genuinely closer to being its last than the one before it. Mission scientists are not being dramatic when they say that. They mean it literally every single day. So the next time you see a headline promising a terrifying decoded message from deep space, it is worth remembering what the real version of that story actually sounds like. Not a warning, not a hidden code, just the true physical hum of interstellar plasma, captured by a machine humanity built decades ago and then essentially forgot could still be out there listening, right up until the exact moment its power finally runs out for good.